a tutorial for the 2 Kinematics concept builders that are going to be due Monday, November 17th, and those will be due at 11:59 p.m. I would strongly suggest you work on those before Monday so that if you have any questions, you can ask me in class. At any rate, those are going to be in this folder. If you want to go to the previous ones we did, they're in this folder, but I usually keep recent things down at the very bottom. So in this folder, there'll be the document that I give you in class. In that document, there's a link to get to the physics classroom. Hopefully you know how to do that anyhow. And then I'll have this tutorial video in here as well. At any rate, when you go to the physics classroom, it should look like this. You need to go to your account. Make sure you log into your account. Wow, I'm not supposed to have any ads in here. That's very interesting. Oh, because I didn't log in, I don't think. So, anyhow, when you do it, you need to log into your account. You shouldn't have any ads. And then you'll see the assignments that are coming up. There's 2 of them that are dated November 17th. That's what you should work on. Any of the other ones were assigned earlier, and those are in the past. Okay, so each one should have a brief description about what you need to do, as well as the handout that I give you. So the first one is, I think, called Which One Doesn't Belong? And I'm going to do this with no task tracking. You want to do it with task tracking. Actually, I'll do it with task tracking. See, I don't think I've done this yet. Oh, I've already done it, so I've got to do it without task tracking. Anyhow, you're going to want to do the first 2 levels. So you want to do the apprentice level, that's worth 4 points. The master level worth 4 points. You do not need to do the wizard level. If you want to do it for extra practice, you certainly can, but these 2 will give you everything I think you need. So I'm going to go and do a couple of them in the master level. Remember, the questions are unique to you. If you need a help you, there's a help you menu down here. There's directions down here. And then you can get to the main menu if you want. So one of these representations is not like the other. Tap the one that doesn't belong. So this shows as time goes along, my position's increasing at a constant rate. This says the object moves with a constant speed. This has a position time graph where the position is constant. So this shows the object not moving. This is moving constant speed. This is moving constant speed. So that is the one that doesn't belong. I'm going to select that. I'm going to check my answer. It should say data away. So some of these will have 3 representations, some will have 4 like this. So this says object is moving to the right, so that's like a motion map, except they don't put arrows on it. Looks like it's speeding up. This one shows an object moving and speeding up. This one says an object speeding up, so those 3 seem good. This one, the problem is this is a velocity time graph. First of all, it shows it going in the negative direction, and then it shows it approaching 0 meters per second, so that's slowing down. So I think that's the wrong answer. But I'm going to pick this one instead. And remember, if you pick the wrong answer, it's going to say, oh drats. And now you get this red, and you have to do 2 similar problems to that. So, and notice that the question isn't identical to what it had before. This shows speeding up, this shows speeding up, this shows speeding up, this shows constant speed. Remember, if you want to tap for help, you can look about the fundamentals, about how to think about the situation. You can look at this particular question. You can look at all these things. You could also go to a certain part in the physics classroom tutorial about all these different representations as well. So those would help you complete that. Okay, so now again, because I missed one of those, I got that right, and it takes it from red to yellow, but I have to get another one in that category. Anyhow, I hope that helps with this. We're going to go to the next concept builder, and that is one with free fall. And so I'm going to go to this one. You do not want to do replay mode. You want to make sure you do the regular mode so it counts. And I'm going to ask you to do these 2, the describing free fall and the speedometer one. So you do not need to do the it's about time one. So I'll do one example from each of these. So baseball's thrown up straight upwards from the ground. and undergoes free fall motion as it rises toward the highest point and then fall back downward toward the ground. What changes, if any, would be observed of the velocity and the acceleration of the baseball as it falls toward the ground from its highest point? So the velocity, and here I generally think they mean speed. So I'm going to say that increases. The acceleration should remain constant. If you're uncertain, take a look in here. So this shows free fall acceleration, means there's no other forces acting on the object, no air resistance. It tells you what's happening when they go their highest point and when they go down. So it is constant acceleration due to gravity. You can look at this also. It's a good example. You can look at these. And then if you want to, you could go to parts in free fall as well in the tutorial, which is the reading online. So all those are available to you. So I think this is going to be the correct answer. And it is the correct answer. So again, you would need to complete the rest of these. There's 6 of them. I'm going to exit that and go back to the main menu so I can show you one from the other. Be careful, if you leave before you're done with a level, it won't be recorded. So you do need to complete a level. So I'm going to go to speedometer 1 now. For the speedometer 1, so it says this ball is projected upward with an initial speed of approximately 50 meters per second. So that's here. And the diagram at the right represents position at 1 second intervals of time. What location would the ball have a speed of 0 meters per second? Well, if you recognize that gravity's acceleration is changing things at 10 meters per second every second, you realize it's slowing down at 10 meters per second every second on the way up. It's 0 meters per second at the top, speeding up at 10 meters per second every second on the way down. And again, you could use the Help Me menu about this question. It didn't seem like that was very helpful. And again, you could go to the tutorial. So I'm going to close that page. But here, if this is 50 meters per second on the way up, after 1 second, it's going 40 meters per second on the way up. 2 seconds, 30 meters per second on the way up. 3 seconds, it's down to 20 meters per second on the way up. Here, it's 10 meters per second on the way up. Here at the tippy top, it's not moving, so it should be letter F. Here would be 10 meters per second on the way down, 20 meters per second on the way down, 30 meters per second on the way down, 40 meters per second on the way down, and this right before it hits the ground, it would be back at the same speed, 50 meters per second, but heading downward. So I think this is going to be letter F. And that's correct. So then you have different amounts of time. So again, this one is asking you what location would the ball be moving upward with a speed of approximately 10 meters per second when it's starting upward at 30 meters per second. Okay. So I hope this video helps and tutorial helps you, and you should be able to get through these based on this background, information on physics classroom, and information that has been presented in class.